In just 45 minutes, a mere 8 lines of dead code that was never even supposed to run, managed to obliterate $440 million from one of the world's most sophisticated trading platforms. This wasn't a cyber attack, not a rogue trader, but a silent, systemic self-destruction triggered by an almost unbelievably subtle oversight. The year was 2012, and KnightCapitalGroup was an undisputed titan of Wall Street. They were a principal player in high-frequency trading, executing millions of orders every single day, often making money on razor-thin margins by being faster than anyone else. Their entire business model rested on the bedrock of speed, precision, and perfectly optimized algorithms. But on August 1st, a routine software update would expose a vulnerability so profound it would almost instantly bring them to their knees. Knight Capital had developed a new algorithm for routing orders, designed to improve efficiency. This new software, known internally as SMRS, was supposed to replace an older version that had handled retail orders for years. The plan was meticulous: roll out the upgrade across their 8 critical servers, testing each one thoroughly before going live. What could possibly go wrong with such a careful step-by-step process? The problem began not with what was added, but with what was forgotten. In 2003, Knight had implemented a testing feature for their old SMRS algorithm. This feature allowed them to test new code by sending small, simulated orders. Critically, this testing code included a feature flag, a simple toggle that would allow it to execute test orders by buying low and selling high, accumulating inventory to fill orders without actually impacting the market. Once testing was done, this flag was always meant to be turned off. Or so they thought. When the new SMRS software was deployed, 7 of the 8 servers received the fresh, updated code. But one server, a single, solitary machine, was somehow missed. It still ran the old version of SMRS. And not just the old version, but the old version with that long-forgotten testing feature from 2003 still lurking within its lines, a digital ghost in the machine. It was dead code, in the sense that it wasn't supposed to be active, yet it remained, dormant but dangerous. The new SMRS system, designed to route orders, had an issue. It would sometimes incorrectly try to send orders to that legacy testing feature on the one unupdated server. On the 7 updated servers, this was a non-issue. The legacy code simply wasn't there, so the order would fail gracefully and be rerouted. But on the 8th server, the one running the forgotten legacy code, it was different. That old testing feature, with its feature flags still inexplicably switched on from nearly a decade prior, was waiting. Imagine a forgotten tripwire in a complex electrical grid. For years, nothing touches it. Then, a new power surge, intended for another circuit, mistakenly brushes against it. This was the moment. The new SMRS, encountering a certain type of order, would misdirect it to the old SMRS on that one forgotten server. And that server, believing it was still in a testing environment, with its inventory accumulating feature flag active, began to interpret incoming orders not as real trades to be executed, but as opportunities to acquire inventory. It started innocently enough. At 9:30 a.m. EST, just as the market opened, Knight Systems received an order to buy 300,000 shares of a particular stock. The new SMRS routed it. One of those misrouted components hit the forgotten server. The old SMRS, in its test mode, thought, aha, I need to acquire shares to fill this order. So it began buying and buying and buying. But instead of filling the order and stopping, it just kept trying to acquire shares, generating new buy orders without a corresponding sell. Within seconds, the system became a runaway train. The old SMRs on the rogue server was buying millions of shares of stock at progressively higher prices, all without any intent to sell them immediately back to the market at a profit. Its primary function was to acquire inventory, and it was doing so with alarming efficiency. It would buy shares and then, receiving another order, it would interpret that as a new instruction to acquire more shares, rather than an instruction to use the inventory it had just accumulated. The sheer volume of erroneous orders began to flood the market. Knight's trading desks watched in horror as their algorithms began to generate hundreds, then thousands, then millions of orders that simply made no sense. They were buying high and selling low, bleeding money with every single trade. It was a self-inflicted wound, a financial hemorrhage happening at machine speed. The trading floor became a scene of absolute pandemonium. Traders and engineers frantically tried to identify the source of the meltdown. They saw their accounts plummeting, their capital evaporating, but the exact mechanism remained elusive for critical minutes. How could a system designed for precision be so spectacularly out of control? The answer lay in those 8 innocuous lines of code, originally designed to help, now actively destroying. For a terrifying 45 minutes, Knight Capital's rogue algorithm bought 75 separate stocks at artificially high prices, creating sudden, dramatic spikes. It sold 41 of those stocks at artificially low prices. It created an enormous unintended position, taking ownership of shares it never wanted at prices it never should have paid, simply because those 8 lines of code with that single feature flag were still active on one forgotten server. By 10:15 a.m., the nightmare was over. Knight Capital managed to shut down the faulty system, but the damage was done. The final tally? $440 million lost. In less than an hour, nearly $500 million had vanished from their balance sheet, the direct result of a coding oversight that had festered for almost a decade. The sheer scale of the financial destruction stemming from such a minuscule, forgotten detail was staggering. This wasn't just a financial loss, it was an existential threat. Knight Capital, a firm worth over $1 billion just hours before, was suddenly facing bankruptcy. They were forced to secure an emergency investment of $400 million from a consortium of other firms just to stay afloat, essentially selling off a substantial portion of their company at fire sale prices. The irony was bitter. A company built on algorithmic speed was nearly destroyed by its own runaway algorithm. The aftermath was a stark reminder of the fragile complexity of modern financial markets. The incident underscored how a seemingly trivial error in a distant past, a simple flag left untoggled in a forgotten piece of code, could lie dormant, waiting for the perfect storm of system upgrades and misconfigurations to unleash catastrophic consequences. It wasn't malicious, it wasn't even a bug in the new code. It was the ghost in the machine, a forgotten remnant of a simpler time, suddenly reanimated with devastating effect. What lessons do we draw from a disaster like this? Perhaps it's that in systems of immense complexity, the smallest oversight can be the deadliest. It highlights the critical importance of rigorous deployment procedures, meticulous testing, and above all, the absolute necessity of decommissioning old code entirely, ensuring that nothing is ever truly dead until it's completely erased. Because sometimes the biggest threats aren't external attacks or grand failures, but the tiny, unseen imperfections lurking within our own carefully constructed digital worlds. This event stands as a chilling testament to how fragile our most advanced systems can truly be, and how a few forgotten lines can unravel an empire.